Albania, has all conditions to apply phytomining. We collect hyperaccumulator plants, but also an accompanying flora to find this other kind of plants. The plants of ultramafic soils during their life has adopted different ecological mechanisms to survive.
Each year, we mine billions of tons of metal from the earth. And the way we do it often comes at a huge cost to the environment. One metal in high demand is nickel, a vital component of electric car batteries, and stainless steel. Now, scientists have discovered a surprising solution, blooming in an unexpected corner of the world. I've come to northern Albania to find out about a cutting-edge approach to mining for metal that could be carbon negative, and it's fuelled by flower power. In the mountainous north of Albania, the earth is made up of a unique composition. The mantle contains a type of rock called ultramafic, rich in certain heavy metals. Over time, as these rocks break down, they create what's known as ultra-basic soils, full of heavy metals, which makes the land unusable for traditional farming. But this landscape is also home to something remarkable, and it's where Sahit Muja grew up. How long has your family lived in this area?
I lived here most of my life. My family has been here for 300 years.
Wow, okay, so you know it very well indeed.
Yes, I do.
Sahit co-founded the startup Metal Plant, which aims to make use of the unproductive land. This looks like lush green farmland to me, but it's not, is it?
Not for agricultural purposes. You can't really grow lots of crops in this land because of serpentine soils. And serpentine soils are rich soils in heavy metals such as chromium, nickel, cobalt, lots of magnesium. Everything that you see here, 150 kilometers, is one of the largest magnesium silicate that has lots of high-grade magnesium content. Those they tend to make the soil poor.
Around 11% of Albania is covered by ultramafic soil, also known as serpentine soil. Nickel is found in this soil. How did it get there?
Well, this is a volcanic rock. So magma has brought lots of nickel and cobalt and chromium, which mean that they are backbone of a green transition from batteries to stainless steel and so forth. And we are mining the nickel and relieving the soil from this type of heavy metals.
It's really beautiful, and I can just see the beginnings of bright yellow crops in the corner. Is that where we're headed?
Yes, it is our metal plant farm. Now you are seeing millions of natural factories. They are solving one of the greatest problems, the land degradation and pollution from heavy metals.
We're just in time to see the crop of natural factories nearing full bloom. They're a type of plant known as hyperaccumulators, which have adapted to grow in these extraordinary soils. Along with Sahit, Metal Plant was co-founded by Eric Matzner and Laura Wasserson, the company's chief operating officer. Hello, Laura.
Hi.
Nice to meet you.
Nice to meet you too.
What am I currently disrupting here? What are you up to?
We are measuring and analyzing and sampling our crop.
And tell me about this crop. It's a beautiful, vivid, yellow-coloured flower, but what is this?
This is Odontarrhena decipiens. It's a type of hyperaccumulating plant.
And what does that mean?
It means that the plant pulls nickel up through the roots into its biomass.
Incredible. Okay, and what is it that you're measuring right now? What do you need to know about the plant?
We're seeing how they're growing, how wide they are, how tall they are, how much biomass there is.
They're currently cultivating around 7 hectares in total, which should produce between 200 to 400 kilograms of nickel per hectare.
What sparked the idea, Laura, for this incredible approach to mining metal from plants? Where did metal plants idea come from?
Metal plants concept is completely inspired by nature. It happens naturally. These plants have evolved over millions of years to pull nickel up into their biomass, and we are working with them to create an alternative source of nickel that's environmentally friendly and sustainable, and it's powered by the sun.
What you're doing sounds really cool, but what are the benefits of this approach compared to traditional metal mining?
You know, metals are what I like to call the dirty secret of the clean energy transition. We need a lot of metals to keep up with our way of living, to create batteries, electric vehicles, stainless steel, all of the things that are fundamental to building societies. And the way in which they are mined does have environmental consequences. So there's a high use of fossil fuels, of chemicals that yield up to 70 tons of emissions per ton of nickel. And the tailings from the mining also contain a lot of these toxic chemicals that make their way into the rivers and oceans. In our case, we're able to mitigate all of that, so we can create not only a carbon neutral and sustainable process, but one that is actually also carbon negative.
Laura, talk me through the process. How does this work?
So the plants pull the nickel up into their roots to their biomass. And when they reach peak flowering, which is in about 2 weeks, we harvest them, we dry them, we thermally treat them, and we extract the nickel.
Will you ultimately clean this soil of all the nickel and therefore not be able to continue doing what you do?
Over time, the nickel can and will be removed by the plants, and we have a system integrated into our process to replenish the nickel using olivine rocks, which also create permanent, scalable carbon removal. But for now, we're working to create as much production and as much output of the nickel as possible.
Metal Plant is one of the first to use this method of metal extraction known as phytomining or agromining on a large scale. They're working closely with a leading expert in the field. For over 20 years, Professor Aida Bani has been studying hyperaccumulator plants at the Agricultural University of Tirana.
How do you identify the plants that are really rich in nickel?
Our foreign colleagues and I started collaborating together because Albania has all conditions to apply phytomining. It is a technology we apply in ultramafic soils that are very rich with heavy metals because they originated from ultramafic rocks that contain more than 70% ferromagnesian materials and are so rich with nickel, chromium, cobalt. We have a very large area. It is about 11% of the surface of the country that is ultramafic. Our team has a lot of expedition in the field, in the mountain. We go in the field as a team, so botanists of Albanian flora accompanying us in the field trips. Sometimes I take with me a colleague. She's Professor Olia Pavlova. She's a botanist from Sofia University. She's the very known botanist of serpentine flora. We collect hyperaccumulator plants, but also an accompanying flora to find this other kind of plants. The plants of ultramafic soils during their life has adopted different ecological mechanisms to survive in this kind of soil. They have a little bit of nickel or other heavy metals. Sometimes we take some filter papers and we do the colorimetric test. This filter paper moisture is wet with dimethylglyoxime, and if the reaction is red, I understand that as more or less nickel, not my lipstick, but nickel.
It does look like lipstick. Oh, you can already see the red colour coming through.
These are from my previous field trips in the north of Albania. I tasted shoots, I tasted leaves, I tasted flowers when I've done in situ phytomining experiments.
Hyperaccumulators refers to a special type of plant with an extraordinary ability to absorb metals at extremely high levels. There are over 700 known species, spread across at least 50 different plant families, and more than 500 of them can take up one metal in particular: nickel. In Albania alone, there are 6 species that hyperaccumulate nickel, all from the same genus, Odontarrhena. The most promising for phytomining are Odontarrhena chalcidica and the yellow-flowered Odontarrhena decipiens that Metal Plant is growing on its farm and can absorb up to 2% of their dry weight in nickel. To figure out exactly how much metal these plants are storing, the Department of Environment and Natural Resources has set up a dedicated lab tracking the nickel content in every batch of biomass. The process starts with drying the plants, then grinding them into a fine powder. 0.3 grams of the powder is weighed, and nitric acid and hydrogen peroxide are added before the mixture is put into a microwave digestion system. The goal is to precisely measure the amount of heavy metals, especially nickel, in the plant. Over the past 2 decades, Professor Bani, along with Professor Aida El-Salahi and their team, have been running trials to improve the way phytomining or agromining is done to boost the amount of nickel the plants can absorb.
First, we only have some in situ experiment bases in the plants that were grown naturally. And we see that these plants, after using fertilizer, improve 10 times the biomass production. The soil suffer not only by the very high concentration of metals, but also the lack of nutrients. So we decided which time to harvest, in which time to use the fertilizer, which agronomic practices to apply. And so every year we improve our process. We play with plant density, we play with soil preparation, we play with irrigation. We don't want to use herbicides, but we use some friendly practice. We use cropping. We take sample and measure in this laboratory sample of plants in different stage of vegetation. We study the phenology of these plants. Always we tend to do most friendly practices because these plants grow naturally, and if we started with 10 kilo nickel per hectare, now we can extract 200 because we improve biomass and we improve nickel concentration. So we improve nickel yield.
I find it fascinating to hear about the work you're doing here in Albania. Why does it interest you so much?
We see this technology a promising technology. We need to do something in this surface to improve the life of people that live in this poor regional area. And why not to profit from these natural resources that we have?
Back on the Metal Plant farm in northern Albania, Professor Bani's research is being trialled at an industrial scale. It's the 4th year they've had a large-scale crop.
It's pretty mind-boggling to think you can go from the bright, vivid yellow-coloured flower I've seen on the farm to metal. Can I see what the end product is?
Yeah, absolutely. So this is nickel hydroxide extracted from our plants, and this is battery-grade nickel sulfate. It has a beautiful color. It's a powder that's incorporated into batteries, and this is incorporated into stainless steel.
And just talk me through the steps to get from flour to that end result.
Yeah, so we first go through a process of thermal pretreatment, which breaks down the bonds of the organic matter into an ash, and then it goes through a series of filtering and leaching to kind of yield the nickel and wash away the other impurities.
To extract the nickel, the biomass is burned, leaving a nickel-rich ash, which is then treated with an acid solution to dissolve the metals. The mixture then goes through a purification process to separate and purify the nickel before being isolated in the form of salts. The team is aiming for a yield of 1 tonne of nickel per hectare, with ongoing improvements to the process.
So this is the operations headquarters for the farm. Here we have stored around me a variety of biomass from the field, from different trials. And from this biomass, we measure and calculate the nickel yields. We also have in this facility our seed bank and additional environmental and weather monitoring.
And so you're always fine-tuning things. That work never ends.
Absolutely, 100%. From agronomic practices to genetic accelerated breeding, there's a lot going on to optimize these plants.
The seeds from their experiments are stored in the seed bank alongside other hyperaccumulator varieties collected from across Albania and Europe.
What's been the result of your intervention in that sense so far?
So these plants have been researched and studied in academia for some time and grown with non-intensive agricultural practices. And through breeding of different species from different regions and through optimizations using more intensive agriculture, we've been able to significantly increase the plant biomass and the nickel yields. And so we continue to innovate in that way and grow these plants even bigger.
You've come a long way since launching this project. It must be really exciting to see the development 4 or 5 years on.
Absolutely. It's like seeing your little baby grow up into a toddler. To be able to create a product, a material that is so needed for the basic infrastructure and lives that we live, to be able to do it in a way that's actually working in concert with nature inspires me every day.
As well as extracting a more sustainable nickel, metal plants added another step to their phytomining operation, one that's allowed them to produce carbon-negative nickel by making use of the ultramafic rock found in abundance in the nearby mountains. The rock contains a mineral called olivine, which holds low levels of nickel. And this is where Sahit's background in mining proves invaluable.
It's nice to take the weight off your feet in this hot weather. Where are we sitting though?
We are sitting down in the world's largest, or 90% of the reserves of green magnesium is called olivine for this green color. Is the resource that have a very high concentration of magnesium. The greenery that you see here, magnesium is the element that stores the sunlight in the cells, in the leaves, in chlorophyll. Then everything, the life drives out of magnesium. So this is the very important element for the world.
And what makes this so special? What makes it distinct?
Magnesium itself is an element that when it interacts with the CO2, it creates magnesium carbonates. So it sequesters the CO2 naturally when it's grinded by erosion.
Geological carbon cycling, also known as the slow carbon cycle, is how carbon moves between the Earth's atmosphere, rocks and oceans over millions of years. Here's how it works. Carbon dioxide in the air mixes with rainwater, forming carbonic acid, or H2CO3. This slowly breaks down rocks, releasing bicarbonate, magnesium, and other ions. These are transported by rivers to the ocean, where carbon is stored for thousands of years. Scientists have found a way to speed up this natural process, known as enhanced rock weathering, which is a form of carbon dioxide removal. Olivine is a very fast weathering rock type, making it one of the most effective choices for enhanced rock weathering. Normally it's avoided because it contains trace metals, but that actually makes it ideal for use alongside phytomining, as it helps replenish the nickel removed by the plant.
There's obviously an environmental impact of mining. How do you qualify that with the work you're doing with metal plants?
You don't have to go and remove lots of soil or deforestate that the magnesium content is all concentrated in a very small area. And so you mine this rock, you process using a green energy, you crush the rock, just a crushing process, you transport and you dispatch in the farm. And this area would turn to a green lake. Let's say that you mine here, we turn to a green lake. We have tried that. The fish are growing beautifully. It's good for recreation. So our technology is mimicking the nature, what happens in nature. This element weathers naturally in the nature with the water and break down in the winter and the summer heat. So we expedite this process. We grind this mineral using a green energy, and we close few kilometers around our farms, and we do this enhanced weathering process where this mineral turns the poison CO2 in magnesium carbonates. Also, we hyperaccumulate the metal for it.
How much carbon can you capture and how much green nickel can you produce?
Well, this rock is a substantial and very big resource, but with 1 million tons of olivine, we can sequester and convert the poison CO2 to magnesium carbonates 1 billion ton per ton. We can at least the minimum produce 3.5 million tons of green nickel, which is current rate that is utilized in the world. So we can supply the world with green nickel resource, and we can sequester billions of tons of CO2. It's one by one, this beautiful rock turns the poison to a rock again, which is carbonates, and has a great effect to land restoration, to ocean restoration.
Here at Reya, we've reported on startups tackling carbon dioxide removal, or CDR as it's known. One example is Nelly in Wales, who are creating biochar. CDR is a certified way of taking CO2 out of the atmosphere and storing it. Every step is carefully checked and audited, and once that process is complete, a certificate's issued for each tonne of carbon dioxide removed, known as a carbon credit. These credits can then be sold. While the idea of removing carbon dioxide from the atmosphere has been around for some time, building a business model around it is still very new. Alongside biochar and enhanced rock weathering, there are other CDR methods too. In 2021, Climeworks opened the first large-scale direct air capture plant in Iceland. It can remove 4,000 tonnes of CO2 per year, a huge achievement, but still only a tiny fraction of what's needed to tackle climate change. Now, by combining carbon removal with phytomining, Metal Plant is producing carbon-negative nickel and planning to sell carbon credits from the process too.
This sounds really impressive, the potential to be game-changing. Why hasn't this happened before?
Well, things have evolved and nickel resource has been depleted, and there's a war now for rare earth minerals. And I have started this journey 25 years ago, first of all, to find the resource, the good quality, the concentration, everything else. Now things are coming together, the minerals and natural-based technologies are merging, and we are doing a very good job so far.
Phytomining faces major challenges when it comes to scaling up. While it can be cost competitive with conventional mining at larger scales, the reality, for now, is production is still limited. But there's growing interest. Metal Plant now offers the option to buy both nickel and carbon credits. That means producers looking to green their supply chains can invest in both, supporting sustainability while securing essential materials.
We have published our results. Also, we presented our results in international conferences. For the moment, this plant, this technology is attracting the attention of a lot of scientists from all over the world.
You bring a value to the land that is not used. You create a job. You sequester the CO2. You produce metals of the future. You enhance the land. So the effect is from economic impact to environment impact. So they are a perfect solution to lots of problems the world has and local economy.
It's definitely possible to scale in other regions, and we're already starting in various regions. We have a grant from the United States Department of Energy, ARPA-E, where we're working on evolving the genetics of these plants, creating sterility, and bringing our crops to other regions around the world.
So what's next for Metal Plant?
So we're working on commercializing our operations, removing the nickel directly from the plants to battery-grade nickel sulfate. We're also working on scaling our carbon removal and delivering against pre-purchased credits. As a startup, we're continuously growing and evolving and working to scale this process, as well as optimizing the genetics of our plants to be able to yield as much nickel as possible.
Even though reducing the impact of nickel extraction and production is just one small part of the environmental effort needed to reduce CO2 emissions globally, Metal Plant is reimagining how it can be done, transforming a traditional industry into one that could play a vital role in a more sustainable future.